Hello, hello. Honors Physics Lesson 1.3, position graphs. All right, so position. This is going to describe our linear location of an object. We usually give that the variable x. And y is going to describe our vertical location. So on a graph, you can have x or you can have y. Sometimes you can even have both. I am going to go on the assumption that you've had some experience graphing before with the independent and dependent variable. So let's go ahead and give that a try. So suppose we have Roy. He's at his house. He's going to go to Bob's Triangle store, and doing so, it's going to take him 4 hours. He stays at this store for an hour before he goes and heads to White Castle in 3 hours. After that 3 hours of going to White Castle, he stays there eating all kinds of food at White Castle because that's what you do, and he leaves and he heads home in an hour. So how would you go ahead and graph this? So I'm going to use these sweet graphing tools here, and I want to use, ooh, this looks like a pretty, oh, this is a pretty color. I like that color. Okay, so let's start with his first part of his journey. So he's going to go all the way to Bob's Triangle store. Bob's Triangle store is at the 12 mark, and so we'll start at 0. And we'll go all the way to the 12. Now, it says it takes him 4 hours. So there is our location there. Then, it says that he stays there for about an hour. So he stays there for about an hour, which means that his position doesn't change. After that, he walks to White Castle, which is at the 3-mile mark, and that takes him 3 hours. So we'll go all the way down to 3. There we go. He stays there for an hour. Oops. Got an extra little leg there. There we go. Sorry about that. So he stays there for about an hour before he goes home again in an hour. So the whole trip takes him 10 hours. Sweet. That's what your graph hopefully should look like. In class, I was knowing a couple of people skip down that hour section. So he does include this hour here. So from 4 to 5, he's just staying there. No change in position. All right, so that takes care of graph his distance that he walks. Check. Find his average speed. So average speed is going to be distance over time. His total distance that he travels is 12 miles this way, 12 miles back, and it does so in 24 hours, so that's 24 miles in 10 hours. So let's go ahead and take that as 24 divided by 10. And that should give us 2.4 miles per hour. That's a 4. There we go. Normally I'd want these in meters per second, but miles per hour is fine for this one, this first section. All right. Then find his average velocity. Well, average velocity wise, he starts at home, he ends at home, so he doesn't have a change in position. So it doesn't matter that it took him 10 hours, it doesn't matter that he walked 24 miles. What matters is he starts and stops at the same point. So his average velocity is 0. Wah, wah, wah. Okay, one more practice problem for you here. So let's go back and look at Roy's graph during his travel time to the Triangle store. Travel time to the Triangle store. So that is this. Fill color, I don't want a fill color. I don't know how to do this. All right, let's just do this. This is his travel time right over here. This is his slope. There we go. All right. What is his average velocity during this time? Okay, so average velocity. So 4 hours, displacement of 12. I don't want it right there though. All right. 12 divided by 4, and that should give you 3 miles an hour. All right, miles per hour. How does that compare to the slope of the graph? So if you take a look at our slope, rise over run, they are exactly the same thing. So the slope of a position time graph gives us velocity. And that's going to be very important when we talk about other sections because when we deal with acceleration, we're going to look at the slope of a velocity time graph. So make sure when you're looking at these graphs, the slope does matter, right? Because right here, there is no slope, so there's no velocity. It's a constant velocity of 0. He's not moving. Okay, that should end it. I will see all of you at a later time and date. Hope you enjoyed or at least got through it. Okay, goodbye.